Resistance happens whenever you have objects in contact. Okay, so like say for your cars, you have frictional force from the ground, and when you walk on the ground, you have frictional force. Okay, and one comment here I would like to add is frictional force. In many cases, there are some bad force for us, but it's not always true. Okay. In fact, frictional force is also a very useful forces for us in many cases. It's one of the most useful force for us, right? Okay, you can see without frictional force, something bad may happen. And you have the experience, probably not here, in another part in the winter, sometimes you have hard time to start your cars on the icy surface. Okay, because to start the car, you need the frictional force to turn your wheel. Okay, so if on the ice surface, you cannot even start the car. Similarly, you cannot work on the ice surface because the ice surface cannot provide enough frictional force to move you forward. Okay. There are different kinds of frictional forces. We have the friction in fluid. That's kind of complicated frictional force. Okay. It's hard to calculate, so we're not going to talk about this kind of frictional force. Okay, for example, the air resistance, because this kind of frictional force, the magnitude of the force depends on the velocity of the object. So, for example, when you try to calculate the frictional force of your cars, the air resistance is not very important. So usually people don't consider it a lot. But for fast-moving airplane, most of the resistance comes from the air resistance. Okay? We also have the static friction and the kinetic friction. Okay? So static friction happens when you apply some force to push the object. Okay? But you fail to move it, so the object is still in the static situation, but in that case, you still have the static frictional force. Okay, that's a force to cancel your external pushing and make the object stay there. But once the object is in motion, then the frictional force is called the kinetic friction or sliding friction. Okay. One more frictional force is rolling friction. Okay, the frictional force happens for your wheel on the ground. Usually, it's much smaller than static and kinetic friction. Okay, so that's why we need wheel for our all kinds of vehicles. Okay, is to reduce the friction. And so, of course, a better way to reduce the friction is to totally kill the contact between the vehicle and the supporting ground. So that's a magnetic levitation train. That can be very fast because you don't have any contact frictional force. These trains, high-speed rail, are magnetically lifted up in the air. Okay, and people even now they even try to propose even faster trains. Okay, so for magnetically deviated trains, they don't have the frictional force from the rail, okay, the track, because there is no contact. But they still have the friction from the air. Okay, and people propose if we can completely enclose those trains into a vacuum tunnel, completely vacuum tunnel. That kind of train can be even faster than airplane. So that's amazing, but of course the problem is, can we find a financially reasonable way to do that? Okay, but it's still feasible because you need to consider the capacity of the train. Okay, compared with the airplane, the train can carry a lot of people, a lot of cargoes. So you can take almost as many as possible cars, okay, in a train. So it's quite effective in terms of, but of course, make vacuum tunnel, that's something beyond our ability so far. Okay. And by the way, I would like to ask you an interesting question. Rolling friction is much smaller than any other kind of friction force. Okay, so that's why we apply the rolling wheels. We invent the wheels for our vehicle. But in the nature, no moving object like all the animals, none of them apply the wheels. Can you try to think about why?
Can't stop.
Hmm?
Can't stop.
We can stop. We can also stop the wheel, right, with the brake. Can you think about why? There is an interesting reason here. In fact, because the wheel is in rotation, so you have to be able to completely detach it from the main part of the car, right? So the wheel is not in, there is no direct contact in the car, okay? It's moving, so there are two parts. Wheel is separate part from the car. It's somehow fixed by other things, but there is no direct contact. If you attach it with a string, then the string will get wrapped, okay, when the wheel is rolling. And so that makes the trouble for the animals, because animal has to supply to connect as a whole body. Like if you animal has a wheel, it has some connection to pump the plasma, okay, the blood to the wheel. But that kind of string to connect them will get wrapped when the wheel is rolling. So that's the basic reason why no no biological stuff can apply the wheel. Okay, but for the cars, it doesn't matter. When the wheel is broken, you just replace another wheel. Okay, it doesn't matter. But for animals, we cannot simply replace their parts. Okay, now go back out to our friction. First, we want to talk about the kinetic friction. Okay, the simpler one among all these frictions. The kinetic. Okay, let's first look at how can we try to calculate the frictional force. And from our experiences, you may get some idea about the frictional force. It can depend on two things. One is the roughness of the surface, right? On a very smooth surface, the frictional force tends to be very small, like on the ice surface. And the roughness of the surface can be characterized by a coefficient, mu. It's called the coefficient of friction mu, okay? So a larger coefficient means a more rough surface. So you tend to have a larger frictional force. Okay. So this is coefficient. And here what we mean by mu s and mu k, because we have on the same surface, we may have the static friction and the kinetic friction. Okay? And in the two cases, the object will feel different kind of roughness. Okay? And the static coefficient of friction is always larger than the kinetic coefficient of the friction. Okay, mu k is for kinetic, and mu s is for static. And you can kind of think it like this way. When the object is in motion, it will ignore some part of the roughness from the surface. so it's smaller. The kinetic frictional force is usually smaller than the static frictional force. Okay? And so that's just one part of the story, the roughness of the surface. Another thing is, of course, the load or the normal force perpendicular to the contact surface. Okay, this one can be willed from the fact that it's harder to move a heavier object because on the same surface, because heavier objects will make a larger load, so it will have a larger normal force to support the heavier object. And this larger normal force will make a larger frictional force. Okay? So if we combine the two facts together, the roughness of the surface, which is characterized by the coefficient mu, and the load, which is determined by the normal force. So the frictional force, kinetic frictional force, can have a very simple form, dk multiplied by n. So it's proportional to both. Okay? This is the equation to calculate the kinetic frictional force. And for the direction, of course, we know that it's a resistance. So it should be opposite to the direction of the motion. So if the object is moving to this direction, this is the direction of the motion. And for this object, the kinetic friction should be this direction. Okay. And this is the kinetic friction acted on the object. From the Newton's third law, we know that any force, there will be a reaction. Any action will come with a paired reaction. So what is the reaction force? Okay? By definition, it should be the same kind of force, same magnitude in the opposite direction, and acted on the provider for this force. For this force, is acted on the object provided by the earth or the ground. So there will be a reaction to the ground. Okay. So this is also Fk, that is acted on ground. This is Fk acted on object. Block. And in our force analysis, we only consider these forces. We're not going to consider the force acted on the ground. Okay. But please note that there is a frictional force acting on the ground. Okay? It's just like when you push the ground is supporting you by a normal force, but you also apply the pushing force to the ground. And another thing is, I would like to emphasize again, this is something we emphasized many times, but it's worth noting here because usually, now you probably know, okay, normal force is not mg, okay, it's always wrong. But of course, when I'm asking you to calculate normal force, you may remember this fact. So okay, you asked me to calculate normal force, I shouldn't be writing it as mg. But many students may forget it when they try to calculate the frictional force. Okay. So when they try to calculate frictional force, they say, okay, I know frictional force is mu kn, and then here they suddenly forgot the fact and they say, okay, that's equal to mu kn. In most cases, it's wrong. Only the weight can be calculated as mg. That's the definition, it's always true, okay? And sometimes the normal force happens to be the same as weight, but not always, okay? And also you can try to guess. In our test, it's usually, I wouldn't ask you any special case where n equals to 1. Now, let's look at one example about